Um, so the subsections. Okay, so basically here, let me say using the true anomaly here. So again, let me highlight and why we want to do the one. Let me highlight here. So those one I circled, those are unknown. We're going to replace. Okay. Those ones are regarding to the one we're looking for, and so we're going to do the replacement there. So here we can do is this. So as long as the true anomaly is determined, and you ask me how to determine the new. And that is following our exercise, our examples. We through a few steps, we can determine this one. Okay, what is new? Again, here this is our orbit. So this is our focus. R0 and V0, and this is our new. So this is our destinations in R, and this is our V. And this is new. Okay, so that's the definitions. And we know from here to here, so from here to here, we have the time of flight, delta t, given, or something. So that is calculated. So that means to this step, we have spent quite a bit minutes, maybe 10 or 15 minutes, and do the calculation to determine this one. And you can say this one, if you like, basically new is the, say, the result of the previous example. Okay, so put that one, we can continue from there. So once we have this one, then basically here the x equal to r times cosine nu. Y equal to r sine nu. Okay, and so here we have x and y. So, and what is x dot, y dot? And x dot, y dot, we can come in from here is this. Remember, we have the velocity expressed in pw. Here I have a note here. Mu over p and minus sine mu and e plus cosine mu 0 in pqw. Okay, in our expression here, everything is in pqw. Okay. So that reason why in the w component there's always 0. That is a parafocal system. So now with this one, so therefore you can see the x component in velocity is this. T times sine nu minus. Okay, and this one is mu over p and e plus cosine. Good. So with those things, we plug in into those expressions, then we have a good result. Okay, so so that one is showing on your handouts. I think in part of your handouts there. I think is in the expressions number 3. Similar to number 3. Okay, you can number 3 in terms of data mu. Yeah, you can convert it. Okay. So okay. So in this way, once you have those things, then basically, therefore, R and V are determined. So once, I think right now you have the MATLAB program, the MATLAB functions we developed in class last time. In that sections, in the MATLAB, that functions, I think we only solve is to the moment x, right? So that means in MATLAB function, Kepler x dot n, I'm talking is this one. So right now in that function, you already have is to the step, and you have these numbers. And probably you can work on your own. And once you have x, then again, you can have x to calculate relating x into I forgot the previous one. So from the functions, you already calculate x. And then from the previous examples, we can see is this. And you can determine the new and from f, okay, or from B or from E. And F and E basically is converted, can be related to X. And see the handouts for the relations. The same thing, see the handout for the relations. So maybe in follow-up, in that functions, you might produce for yourself is this. Once you have X, and what will be the corresponding those values. And once you have those values, what is this one? And once you have this one, then pretty much in the follow-up a few lines, you can write it up as this. You can calculate f equal to functions of new, and g and f dot, you can put into f dot, and g dot equal to the function 1 and function 2 of new, and function 3 of new, and function 4 of new. And here, those functions, you simply is quickly implement those kind of expression here. Okay, plug in those expressions, then in this way, in your final two lines, you are equal to something, something, then you have the result. And the same thing D here. Are we good? Of course, you can always do this calculation by hand, but in preparing for the final test, and if you have those things handy and be benchmarked, verified by doing homework or examples, I think this should be very useful. Okay, so simply edit up a few lines and follow up those things here. Okay. So that is in terms of new, and the next one in terms of x. So here for the x, I will do a portions and then leaving for details. Okay, so that is handy. So if we have x, then right away, basically you can from x directly jump into these things. Okay, so as long as the x is determined, and this one again, this is on the handout, and let me write it up the result to you first. So x will be equal to x squared divided by R0C, and oops. And again, this one is on your handouts. You can refer to there. And here S and C are the particular two functions we defined in this chapter. Individual expressions is quite a bit involved. And let me show you F here. And let me utilize these things to do this one quickly. And for this one, this is in our textbook 4.4 is in our BMW textbook section 4.4. Okay, you can refer to their details. And let me show you why the F is like this. And from F, previously we've been calculated is x y0 dot and minus y x0 dot 1. Okay. We have to do that. Okay, let me do this one quickly. So right now my effort is replace x, y, x dot, y, the kind of x, y components in terms of the x. And this one will go back to using our orbital equations and the beginning of the universal variables. So let me try this. So by the orbital equations, and that is 1 plus e cosine nu, and this one, a minus e squared, and 1 plus e cosine nu. Okay. And so therefore from here we can have is re cosine nu equal to a 1 minus e squared minus r. I simply multiply the denominators into here and rearrange the result. And if you don't like, you can just watch. You don't need to write because everything is in our textbook. I just want to show you this one quite a bit involved. So now with the r equal to a times 1 plus e sine. And this is a way we kicking into our universal variables. This equation is the first time seen in the very beginning of the sections when we talk about the universal variables. Okay, and I dig out that one from there. So therefore, in this way, you can see r. So now I want to replace this r by this. Okay, so therefore, re cosine nu equal to a 1 minus e squared and minus this one a minus ae sine. Okay, and we do the arrangement. So therefore, from here, the x will be equal to r cosine nu. And this one will be equal to minus a E plus psi. Okay, so we have these informations, and I copy to here. So that is the information obtained to here, and also this information is regarding to x. So we have the x appeared, okay? And we have x appeared, so therefore x equal to this one. And also y, we know the using tangential ray coordinate systems is the r squared minus x squared. Okay, so therefore we can have y. So that y equal to a times e squared and cosine x plus c0 square a. So this is y. So basically here we have patterns appeared. For this one we have xy0, etc. Okay, so that is successfully linking into our universal variables. So the remaining is simply we introduce the two templates into here, and for 0 that means our initial conditions, and for initial positions, remember in our calculation of universal variables we define that equal to 0. Okay, so again we simply introduce the two templates x, y into here, and for whatever the initial positions, the x0 will become 0, and then spend another 15 in terms of my time. Probably you will need more, and then go through, then you will get this one. Quite a bit involved, and our textbook have a detailed document every single detail to this step, and you can refer to there, but I don't think that is important. For our usage, we simply want to adopt the final form. The derivation is not critical. Okay, so again, given those things, then in your programs, so say if you already have the x, so either you can calculate through anomaly to determine this one, or optional, you can use an fg, f dot g dot in terms of x. Then I think this way, f equal to the function of x, and g equal to function of the x, and etc. This will be handy, because to the end of the program you already have this one term calculated. You directly jump to here, then you can skip maybe a few lines of the calculation for new whatever. You know what I'm saying? Okay, and I think our textbook have 1 or 2 examples, and then coming back here, I have other one more example. I can show you the whole process. Good? Okay, thank you.